Welcome to today's webinar, Building Camera-Enabled Smart Home Devices at Scale. I'm Charlie Hamill, Principal Enterprise Architect with AWS, and joining me for questions today are David Robo, Global Business Development with Kinesis Video Streams, and Girish Sood, Senior Product Manager of Kinesis Video Streams, both from AWS. The connected home market is growing rapidly, and IoT applications are rapidly becoming smarter, especially camera-based products. The market is competitive and growing, and camera-based products are a cornerstone of the smart home ecosystem for a couple of reasons. First, cameras are often the first thing a customer buys. Security is a top priority with them. And secondly, cameras are high value for the smart home vendor, with recurring revenue opportunities, such as cloud storage of video and advanced AI and ML features for monitoring pets, children, and elderly people. Now, the connected home market has several use categories. The one on the left is home automation, and that's about controlling things like lighting systems and appliances, entertainment systems, small appliances, and so on. On the bottom, we have home networking, which is about Wi-Fi routers and modems or cable set-top boxes. And then there's the category of home security and monitoring. That's where we have security cameras, door locks, door sensors, window sensors, thermostats, water leak detectors, and more. Now, you need to focus as a producer of solutions for this market on differentiating your solution. It's a very dynamic market with new entrants all the time, and you need to stand out. You need to constantly look at optimizing your cost and accelerating innovation for your customers. Now, you might think the barriers to entry to this market are pretty low. The barriers to entering well can be high. Well, what do I mean by entering well? Well, you can source some cameras, get some cloud servers, build some software, get the cameras to stream video back to your cloud applications, build mobile apps, and you're there. But I just named at least 3 things that can be big barriers if you don't choose well. Sourcing cameras, building applications on servers, and building too much application software. And add to that building connected home devices is further challenging by these things. It's hard to maintain interoperability between multiple vendor devices. You need to ensure devices work regardless of local connectivity to the network. And you may be facing a lack of a reliable and scalable global cloud infrastructure platform. And you need to ensure secure connections and maintain compliance. And then add to that building a video system is complex. It's cumbersome to rewrite your code for various camera devices and development environments. And you need easy to use APIs to retrieve, replay, and process video at any scale. And this requires a reliable support for cadence, latency, and jitter on video streams. And it can be difficult to elastically scale to millions of devices. And if you're not elastically scaling, then you're provisioning to peak, which can be pretty expensive. And it requires secure streaming and storage by default. So remember, this market demands fast innovation with a focus on cost. So those 3 barriers I mentioned, source your cameras the easy way. And secondly, build your applications on serverless solutions that can scale massively, where you don't have to buy, spin up, or manage servers. And then thirdly, don't build too much software. Combine IoT and serverless video streaming services to get your streaming and analysis and playback, and maybe even add AI to that. And with this combination, you have a powerful solution at a pace of innovation and scale and price that makes business sense. So let's look at them. First, sourcing cameras. Now you have a number of options for sourcing cameras. You could choose a white label service. Somebody else is providing the camera for you. And the pros there is that it's a proven solution. It might be a moderate initial investment, and the time to market can be quite quick. The downside is it's hard to differentiate yourself with that kind of a camera. It can be hard to integrate with the services you need to use. And you may not have access to customer insights that you need to constantly optimize your solution. And you might face ecosystem lock-in. The second choice is you could build and manage your own platform. And with that, you've got full control of your destiny. But the downside there is it's a high initial investment, a long time to market, and your ability to deliver, scale, and be flexible with that choice can be pretty uncertain. Thirdly, you could just buy your way in. Once again, you get full control of your destiny, but the downside is that's a high initial investment. For instance, Ring initially raised $200 million and was acquired for $1 billion. Alarmforce Industries acquired by Canadian telecom giant BCE for approximately $184 million. Well, there's a fourth choice. You could use a product marketplace, source your cameras from another brand's hardware and services. And with that, I'd like to introduce you to AWS Partner Device Catalog. That's your partner for cameras. The AWS Partner Device Catalog connects you with original device manufacturers, or ODMs, and they list only qualified hardware that integrates with AWS services. Companies like Altec, Sercom, Technique, Skylight, Chicony, they provide a variety of reference designs for indoor, outdoor, LTE, doorbell camera products, and they include off-the-shelf integration with AWS SDKs. That's plug-and-play integration with AWS infrastructure. So we've talked about the first barrier that you can choose to do well, and that's sourcing your cameras. Now, the second one is about choosing to go with serverless applications instead of managing your own servers. So with AWS, you can choose something called Amazon Lambda, and you simply write your application code and deploy it on Lambda as functions, and AWS manages the compute platform for you. And you shed all the effort that goes with managing servers, and you free yourself up to focus on creative innovation and moving faster for your customers. And there's a number of supporting serverless solutions to building those applications, such as serverless NoSQL database and serverless asynchronous messaging that you can take advantage of. And point number 3 builds on number 2, and that is don't build too much application software. For instance, in this space, we have a number of foundation services that can help you with the job of managing millions of devices and handling billions of messages. And let's take a look at them one at a time. Firstly, we have AWS IoT. You can look at AWS IoT along 3 lines: data services, control services, and device software. Device services help you answer the question how you extract value from your IoT data. Control services help you answer how you can control, manage, and secure your devices. And device software is about how you connect to your devices and operate applications at the edge. Specifically, data services at their foundation include IoT analytics, and on top of that, we offer IoT Sitewise and IoT Events. Control services at the foundation includes IoT Core. On top of that, IoT Device Management, IoT Device Defender, and IoT Things Graph, which is a great way of visually composing complex applications interacting with all your disparate devices. And on the bottom, under device software, we have Amazon Free RTOS, which is a free real-time operating system for microcontroller-based devices, and AWS IoT Device SDK, which enables these devices to interact easily with IoT core services. On top of that, on edge devices, you would deploy IoT Greengrass, which is a way of hosting applications that you write. So why use AWS IoT for camera-enabled devices? Well, first you can think about doing machine learning inference at the edge. So AWS IoT Greengrass makes it easy to perform machine learning inference locally on devices using models that you create, train, and optimize in the cloud. And then once the inference models are running at the edge, you can continue to send data from these inferences back to the cloud to Amazon SageMaker, which is a machine learning development environment, and it can continually optimize your model based on what it sees happening. Also, it's important with camera-enabled devices to maintain offline communication. Connected devices should continue to operate with each other even if they lose communication back to the cloud. Synchronizing the data from the cloud whenever connection is reestablished. And then thirdly, you need a quick response time when events happen in the home. So IoT Greengrass devices can process and act on data locally to respond quickly to local events without the round trip to the cloud. And next, you can gain intelligence and insights from IoT analytics using predictive insights on usage patterns for smart home devices. And it's important to be able to scale securely and using proven cloud infrastructure that scales to billions of different devices and trillions of messages. And AWS IoT includes preventative security mechanisms such as encryption and access control to device data. AWS IoT also offers a service to continuously monitor and audit the security configurations. And you can receive alerts so that you can mitigate potential issues such as pushing a security fix to a device. And with all of this, you get IoT Things Graph, and it makes it easy to rapidly build IoT applications by connecting devices and web services from different vendors that speak different protocols. The next foundational serverless service that we want to talk about is Kinesis video streams. Kinesis is a family of streaming services from AWS that started out with data, Kinesis data streams, and then continued to data firehose, and then data analytics. And now we have Kinesis video streams. And the way Kinesis video streams works conceptually is over on the left at point 1, you have video-enabled devices, such as a camera or a smartphone, or even an audio device. And if they have in them the producer SDKs that they need for communicating with KVS, it makes it very easy for you to build applications on those devices that send video or audio to Kinesis video streams. At step 2, Kinesis video streams in the cloud provides APIs for consuming video in real time. And you can stream video to custom applications you're building for the web or for mobile applications. And then going down to step 3, Kinesis video streams also stores the video durably across 3 availability zones in a region. So KVS is a highly available service that you don't manage and is deployed across 3 availability zones in a region. And by storing the video in its storage system, it enables you to come back with applications and using a time index storage API to retrieve video at any point you want. And then lastly, you can offer all of this to your customers through custom applications. So why use Kinesis video streams for home security and monitoring? Well, first, it's a fully managed service. You don't have to worry about configuration, software updates, failures, or scaling infrastructure as the number of streams and consuming applications grows. Kinesis video streams can ingest data from edge devices, smartphones, and security cameras, and other data sources such as radars, lidars, drones, satellites, dash cams, and depth sensors. And Kinesis video streams provides SDKs that make it easy for devices to securely stream video to AWS KVS for playback, storage, analytics, and machine learning, and other processing. And you can easily build applications with real-time computer vision capabilities through integration with something we call Amazon Recognition Video, which is an AI service that allows you to send video to an API, and it will identify what's in the video with bounding boxes or identifying familiar objects like furniture or pets or even famous people. Or you can do real-time video analytics capabilities using popular open source machine learning frameworks with a custom model you build. Kinesis Video Streams enables you to control access to your streams using AWS Identity and Access Management, or IAM. It helps you protect your data by automatically encrypting the data at rest using AWS Key Management Service, KMS, and in transit using industry standard TLS protocol. So here's a machine learning inference using a reference architecture using something called Kinesis Inference template. So at step one on the far left, we have Kinesis video streams delivering data coming from any number of sources. And an application running on AWS Fargate, which is a managed container environment where you can deploy an application and not have to worry about the containers or instances. And that's consuming the stream in real time. And the first thing it does is checkpoint the stream processing status to Amazon DynamoDB, which is a serverless NoSQL database. At step three, it's also sending the decoded frames to a machine learning model hosted on Amazon SageMaker. It gets the inference results back, and at step four, posts the inference results to Amazon Kinesis data streams as messages. And a consumer of that data stream is here, AWS Lambda, which is a function that responds to events arriving in Kinesis data streams. And it does something interesting or important with the results of that inference, like sending it somewhere or sending it to a database for analysis. So let's put all this together with a couple of use cases. The first use case is an integrated security solution. Here you see a front door. And on the left at the top, we have a connected security camera with a machine learning driven insights model running in it. And in this case, it's able to detect someone it doesn't recognize. It's trained to recognize family members, and those that aren't, it considers somebody you might be interested in knowing about. Over on the right-hand side, we have a smart outdoor lighting that can turn on automatically when it senses someone approaching the door and allow the homeowner to remote control it. Below that, we have a camera-enabled doorbell, which can show the person arriving, along with being connected to the smart door handle and door lock that allows the homeowner to remotely allow a guest into the house when he or she recognizes who that person is. Let's take a look at another use case. Here's a pet monitor example. So on the far left, we have in the home a camera that's got a machine learning model deployed in it, and it's trained to recognize when a pet is in the scene. In this case, it's choosing to send video to Kinesis video streams, but only when a pet is in the scene. Kinesis video streams receives that stream of video, and a video processing application consuming that stream can become a pet monitor, mobile or desktop, desktop web application for the pet owner to view anywhere, anytime. So with this combination of services I've been showing you, you can rapidly and securely connect, provision, and manage your intelligent camera fleet with AWS IoT and stream your output to Kinesis video streams for further processing, storage, playback, and analysis. Let's take a look at some of these visually coming together. So on the far left, we have in the home two stacks of things. On the top, we have CPU-based devices like a security camera, a Wi-Fi router, home controller, and they're all running AWS IoT Greengrass. And below that, we have microcontroller-based devices like a door lock, light bulb, appliances, and they're running, say, free RTOS. They are able to communicate and interact with AWS IoT core in the cloud. And the security camera, in addition, is choosing to stream its video to Amazon Kinesis video streams. Once all of this is in the cloud, you can build rich applications using other AWS core services like machine learning, databases, and compute infrastructure. And with all of that, you can deliver powerful mobile apps to your customers, or dashboards, or even Alexa interactions for the customer. Let's go down a little bit deeper with a couple of reference architectures. This reference architecture is going to look at doing machine learning of video in the cloud, a fairly traditional, conventional approach. So we're not deploying it to the edge, we're doing it in the cloud. So the way we do it here is start with step one, and inside Amazon SageMaker, you can build, train, and optimize your machine learning model, and then deploy it onto a GPU instance, and consume and interact with that model with an application running in AWS Fargate. So let's look at this coming together at the bottom at step three. Here we have in the home, let's say a camera that has AWS Greengrass core, a Lambda function, and that's it. And it's choosing to stream telemetry over to AWS IoT core in the cloud, where we have Kinesis data streams consuming that telemetry, an AWS IoT channel as the consumer of that data stream, sending that data stream content over to AWS IoT Analytics at step 5, and then finally to AWS IoT Events, where you can write simple if then else statements to decide which events you actually want to act on. Then going to the bottom path at step 7, the Lambda function is also sending all video to Kinesis video streams. And at step 8, we have that Fargate hosted application consuming the video streams in real time continuously. And that application is choosing to send the video stream to a hosted machine learning model in G3, a GPU instance. And based on the inference, it's choosing to send certain video streams over to a mobile application, such as a baby monitor, an elderly person monitor, or a pet monitor application. Now let's flip that around a little in this reference architecture. We're doing things a little bit differently. Starting at step 3, we have Amazon SageMaker again. And this is where you build, train, and optimize a model. But you can do one additional thing if you're targeting edge devices. You can optimize this model and compile it directly for the device you're going to run it on. And by doing that, it can be 1/10 the size of a GPU-based model. Secondly, you're going to deploy it from SageMaker, and there out on the actual device in the home, you end up with the model, a Lambda function, and Greengrass core. So let's put this together at the bottom, starting at step 6. Step 6 is in the home, a device, let's say a smart camera, with the machine learning model executable running on it, Greengrass core. And this device is choosing to send video events, which are data, over to AWS IoT core as we did in the previous example. And it follows the same path. This time, however, it's choosing to send only video frames that have a baby in them. And so it's not sending everything. And it goes to Kinesis video streams. And from there, it goes straight to a mobile application. Now you might see the difference here. In the cloud, you have much less going on. You don't have GPU instances. You don't really have much of an application going. You're taking advantage of the compute capacity available in your thousands or millions of CPU-based smart devices out in the field to do machine learning inference. That may be an appropriate model for your application. It may not, depending on how much video you're trying to deliver to your customer. So here's a more elaborate sort of reference architecture showing a number of use cases. One of them is where we have video fragments uploaded to KVS where they're indexed and stored for 30 days. End applications can play back the video in live and on-demand mode with HLS, which is HTTP live streaming. The next use case here is where video is automatically time indexed in KVS. The camera can send thumbnails with the time of motion event to AWS, where a Lambda function can store it in S3 and index the S3 object location and timestamp in DynamoDB. And with that, a player application can create the timeline from the motion event thumbnails and get the corresponding video for playback from KVS. And then the last use case here is where KVS will provide a software library packaged as a Docker container with automated deployment through AWS CloudFormation. This software will enable attaching KVS to deep learning models running in Amazon SageMaker. And this capability manages processing of media from the KVS APIs, sampling and decoding video frames, and interactions with Amazon SageMaker. And this includes invocation of a SageMaker endpoint that accepts images and passes inference results into a Kinesis data stream. So these AWS solutions that I've been mentioning are really impacting the industry. Xfinity, Comcast, for example, managed to save 26% over their custom-built solution on premises by moving to AWS KVS and IoT for their home security product. A global consumer electronics brand added 4 camera products to their smart home catalog using AWS KVS in just 6 months from start to market launch. And regarding growth, a fast-growing DIY camera company migrated to AWS KVS and IoT in 4 months to scale to 4 million plus camera devices and accelerate their growth momentum. So with lower cost, we're seeing an impact when customers allow AWS to handle video and IoT infrastructure to remove complexity from their solutions. And that offers them a fully elastic and predictive cost model at any scale. And it lowers the TCO compared to custom platforms. And we see customers accelerating velocity by focusing their creative resources on product innovation and time to market. By leveraging video and IoT analytics, they can scale to score video in real time. And we're seeing customers unlock growth. With KVS, for instance, you've got a 99.9% SLA for a scalable, reliable, and compliant platform. And both KVS and IoT offer you a massive global scale for large customer deployments. Now it's your turn. You can get started very quickly. First, you can take a look at the KVS tutorial. And this, if you get yourself a Raspberry Pi with the camera module, you can begin streaming video from that camera module into KVS and out to a consuming application very quickly. You can also go to the AWS IoT Camera Quick Start. And with that, you can see how you can manage your cameras from AWS IoT. And you can also take a look at the AWS Partner Device Catalog and see the number of vendors we have who produce reference architectures suited for your particular application. Well, thank you all for joining us today. And I'm Charlie Hamill with AWS, and there's my email address where you can reach out to me. And joining us also today, handling questions, were David Robo and Girish Sood, and you can also reach out to them. Have a great day.